Hello and welcome to Lesson 4, Video 1 for Redox Reactions in Chemistry 2. Today we're going to learn about redox stoichiometry. It's really nothing new. We're just going to put together our knowledge of stoichiometry with our new knowledge of redox reactions. So, the first thing we're going to do is balance the redox reaction. So this is going to give us our mole ratios. So that is going to be our first step. So you have to pay attention whether it's acidic or basic for the half reaction method. And then once we balance it, we have our mole ratios that we can use for the stoichiometry. So we're going to use our tools that we already know. So either grams or volume to grams or volume stoichiometry. So we know that if we have a volume, we're going to use the molarity of something. If we're given grams, we're going to use, we can use the formula mass of things. So we use molarity as a conversion factor, just like we've done in the past. So that is moles over 1 liter. So we can use formula mass, where we have the grams, which is our formula mass, per 1 mole of that substance. And if we have gases, if you remember back to Chem 1, we had a relationship between how many liters of a gas per mole at STP. And if you remember, that's 22.4 liters of gas per 1 mole at STP. So standard temperature and pressure, 1 atmosphere pressure and 273 degrees Celsius or 0 Kelvin. So what we're going to do is we're going to look at 2 example problems. And that's the last page of our note packet. So here we have an unbalanced redox reaction. It's acidic. So if you want to pause this video and go ahead and balance this redox reaction using a half reaction method acidic, now would be a good time to pause it. I'm just going to go ahead now and write down these. So pause now, solve, and then come back. So welcome back. If we were to do this, we'd end up with a 3 in front of both of the sulfur, either compounds or ions, and we would have 3 waters and 6 H plus on the product side. So that's what you should get if you balance this out. Now, our first problem says that 35.8 milliliters of a 0.995 molar solution containing a chlorate ion reacts with 25.6 milliliters of SO2. What is the molarity of the SO2? So we are starting with this. And this. What is the molarity of the SO2? So we know how many milliliters of SO2 we're going to have to solve for molarity. So when we're dealing with stoichiometry and molarity, if we're given milliliters, we have to change them to liters. So that's the first thing that we're going to do is change that to liters by dividing by 1,000, so 0.0358 liters. Chlorate ion, ClO3 minus. Now, I want to use this molarity. Remember, that's moles over 1 liter. So 1 liter of the chlorate ion solution has 0.995 moles of the chlorate ion. And now is where our mole ratio comes into play. Remember, mole ratio is how we go from moles of one thing to moles of another in a balanced reaction. Well, we have 1 mole of chlorate per 3 moles of sulfur dioxide gas. Now, if we start crossing off our units, all the chlorates cross out. We want molarity of SO2. Remember, molarity is moles over liters. We have moles of SO2, so our last thing is we're given how many milliliters, which we can convert into liters. We're going to put that in the bottom. I'm not going to put anything up there because our units left will be moles over liters, which is molarity. So I'm going to calculate this out. Remember, we multiply when things are in the top, we divide by when things are in the bottom. And we're going to look at significant figures. So everything looks like it has 3 in the problem, so we should have 3 significant figures, and we get 4.17 molar SO2 as our answer. Our second example, we're going to use the same equation. It says how many liters of 0.485 molar solution containing chloride is produced if 75.4 milliliters of 2.18 molar solution containing chlorate ion fully reacts with the SO2. So we're going to start with the thing that we have the most information of. And we're given another piece right here, but we want to know how many liters of chloride. So we're going to start with our liters again, and we're going to convert the milliliters into liters. So 0.0754 liters of chlorate ion. This time we have 2.18 moles per liter. So 2.18 moles of chlorate per 1 liter of chlorate ion solution. And now our mole ratios between chlorate ion and chloride ion. And if we look back up at the equation, they're 1 to 1. So 1 mole of chlorate to 1 mole of chloride. Now this time we want to go to liters, and we're given a molarity. So we want the moles to cross out. So far, what hasn't crossed out is moles of Cl. So this molarity tells me that I have 0.485 moles of chloride per 1 liter of solution. So that allows that to cross out, and we're left with liters. And when we solve for this, 3 significant figures, 0.339 liters of chloride solution. So you should be able to do the worksheet now that is in Schoology.